This is a small presentation about Elixir. And this was my stupid idea to present you why Elixir. It's a good language to sell and a bad language to sell at the same time. And I'll show the pros and cons. So I've created the next big startup, the next Portuguese unicorn, which is the emoji board. And let's start. Who am I? I'm Filipe Cabaço. I'm a developer at Expert. Those are my handles, and since it's a quite rare name, that's my handles for everything, even PSN. So, this showcase will touch on processes, on supervision and distribution, and some tricks and tips. Just some stuff that you'll probably like from the language. So, what is Elixir? So, it's a new language created by José Valim. I advise you to follow him, and if you ever have any doubt why he built Elixir like it is, check out his talks. Basically, justifies everything. He's a really good talk. It has a Ruby-like syntax, so it's really user-friendly, and it compiles to Erlang, which is the Vim VM. And why is that important? So that's really important because Erlang was an old language that already uses really new concepts like imitability out of the box, so it has really smart data structures around it. It has processes which are basically really lightweight things above threads, and they're really smart on how they use memory, they're really smart on how to use resources, and above all, they use messages to communicate between them, and that's really good for concurrency and distribution because you can have basically a bunch of nodes connected, and for most part, it will be completely transparent for the application. So it's a really powerful VM. And if you ever need to choose between Elixir and Erlang, to be honest, either syntax looks good in my opinion. The Erlang one is a bit more prologish, so you might feel a bit uneasy with it. The first one, I think it's better, but that's personal opinion. Anyway, I would advise to test out Erlang, test out Elixir. They're really interesting languages. But now, going back to my $1 million idea. So, our objective is, our objective on this talk is have a small system that receives a file, that's basically a front-end React thing, receives a file and sends it to a worker that calculates the grayscale and sends back an image pixel by pixel. And each pixel will be an emoji. This is our current system. It's in my GitHub, I'll share the link later, where we have our server, where our Elixir app lives, and most of the code will be done. We have a client, which is just a simple React app, and we have a worker, which is a bit of a special sauce. I left, and we'll see why. That basically receives the image and translates each pixel to basically an alpha value. So it brings back the transparency so the front end can actually display it. So our contracts/actions is to process the file, receive the pixels, accept new WebSocket connections, and then send those pixels through the WebSocket to the front end. So let's actually get started. I'll show you how to create a supervisor. I will not show. To be honest, I'm a bit lazy. So this is an Elixir supervisor. What's happening in this code is basically, and I want to create a module that is a bit smarter, that does a bit more than usual. That more than usual is the behavior of the supervisor. So to start with the supervisor, you do dev start link, which is something the supervisor will call. You'll do supervisor start link, which is imported from supervisor, and then you have this init. Init is basically saying to the supervisor, okay, what's my way of starting up? So this module, within this full module, you have all the logic and life cycle of this application. Other things that are important, a supervisor can have a name, That name is basically the unique identifier that will be used inside Erlang VM. You can call it back. And another important thing is, I've just said a lot of stuff, but I didn't show you how I learned this. So I'll take the opportunity to actually show you something which is beautiful, which is Elixir as a REPL. So everything in the documentation that you have in the web, you also have in your workstation. So basically the docs are really complete and they show you what to do. You can basically copy paste and it will work. And now that I've said a lot of things without any meaning, because I need to explain what is a supervisor. So again, this was extracted from the documentation, a lot of mumbo jumbo, but the lesson here is a supervisor is a special guy that is the boss of other guys. So imagine your manager. If you do a bad job, if you misbehave or anything, you'll die, and the supervisor will bring up a new worker, free of charge, and just brings it up. This is a concept that is really used in Erlang, which is the idea of kill it. If the process is not doing anything well, if your sub-worker is not doing something correctly, it will die, but it will be killed, and just bring another one. So it's basically, it's easier to kill than to fix, which sounds really bad, but still. Now, trust me, everything will make sense in a bit, which is now we need to create that worker. So we've got the manager, we've got the worker. Now we have the manager, now we need the worker. So by uncommenting this and by going to application, you can actually start up this. This is how I start up the boss. Basically the boss has another boss, so this is the CEO. The CEO needs to understand who are my the other C's in my ladder. So this is where we started, and now let's actually create the worker. Again, there's a concept in Elixir, and not only Elixir, in Erlang, which is the gen server. Gen server is nothing more than a contract around the message passing that Erlang provides you out of the box. So basically Erlang is really smart that in the sense of one process just needs to know the address of another process, and then the second one has a mailbox. So it just sends messages, just keeps bumping into the second guy. The second guy just goes, okay, I'll process at my own time, I'll respect the order, and so on. So gen server, it's actually an abstraction above those messages, just give us a bit of a cleaner contract. In this code, for example, we start to see another, again, sorry, I'll just show you that start link. It's really easy. You just say gen server start link. You'll give it state in the name. That's fine. Done. You'll give it the definite. That's just coding convention, and it just works correctly. Now, the gen server needs to comply. It doesn't need to comply. It gives you those two calls. So and the call are just the contracts around the gen server. What this means is that whenever we receive a message with this structure, that message will fall into this guy. And this is another good feature of Elixir, which is pattern matching. Some of you might have seen this in Scala, or I don't know, even Clojure can do it in a sense. This is really powerful. Again, this gives your code a really good view, and that's another advantage that I'll explain later. But basically, you can give the full contract here, and it works really well. And if you receive a message that doesn't fit this, your worker doesn't know how to handle it. So your worker basically goes, oh, damn, and dies. And then the manager will arrive and say, yeah, I need a new guy. That guy just died in the corner. Bring another one up. So this idea of just failure, failure, failure just piles on, but you always have a guy to pull your shoulders back up. So now that we know this, we actually need to say to that manager, okay, who is my worker? Nice, it's emoji process. So at this point, emoji knows that he has a new worker. That worker is emoji process. Done. And to prove it, if we go here to our repo, and we do gen server .call. I hope this goes well. There is emoji. Oh, sorry. I have the client open. That's basically saying that the socket is connected to Phoenix. But that will come later. The guy is just annoying me a lot. That's part of it. Emoji.process. And if I send a message, this is the typical message of I don't recognize this. I don't know what the hell did you send me? And the guy dies from shock. So the manager at this point already brought up something else. And if we actually do this, it's actually an image. And we give it a path. Then hopefully we'll actually recognize something from this. Yeah, so the worker now understood the message. It basically received, okay, I want to process an image and it's on that file. Cool. This is the file button. That's it. This is just a byte string array. Done. That's it. So, and another way to prove that we have a worker, it's another advantage of Elixir having Erlang beneath it. Since it was a tool that was really, really well developed, it already has a lot of stuff to support it out of the box. This is known as the observer. This guy can connect to an Erlang VM and give you metrics over everything. It's a really cool example. So as you can see, in our giant tree, we have our CEO, we have our manager, and we have our worker. This guy is clearly a more important manager guy because he's handling the web service. That's why he has a lot of, yeah, this guy got a promotion. It has a lot of processes underneath it. And you'll start to see this a lot. In Erlang, the basic way to work is, in doubt, create a new process, and you're basically creating not microservices, but nanoservices. Each guy has its own intelligence, it does its own thing, they're really specialized, and if anything happens to them, please kill them, because the boss will bring them up. So that actually covers the side of the emoji process. So you've seen handle call, you didn't understand what that implies. So I'll explain you the contract of Gen Server. Gen Server, which is, again, behavior on top of the Erlang messages, it's just a way of them to say, okay, if I want to do a call, what does a call mean? What if I want to do a synchronous call? Okay, cool, that's it. So it just gives you a subset of things and a way to do something that doesn't involve you programming directly. It would be a lot of boilerplate. You need Alice to know how to send a message. You need Bob to know how to send a message to the guy that sent it to him. So there's a lot of logic there that probably would end up really, really, really badly because usually developers fail a lot doing boilerplate. Most of the bugs probably come from there. So this gives us that tool. See, it's production tested, whatever, it works really well. And what the three types of ways of doing Gen Server stuff, it's handle call. It's when you want Alice to send a message to Bob and get a response. So it's a synchronous call. It's It's when you want, okay, I want some feedback. I want to have some information back. An handle cast, which is a cast, it's basically, okay, fire and forget. I'll receive a message, do whatever I need to do, and I won't send anything back. The guy doesn't care, I don't care. That's it. And then handle info, it's more of a making sure nothing blows up, because handle info is for everything else. So Erlang, since it lives on top of the messaging system, handle info is the guy that basically goes, okay, if the other worker doesn't comply to my contract, at least I'll have a failsafe. This guy catches whatever it's not correct. We'll have an example of that later. And let me remind, yeah. So as you see from the observer, it looks really similar to a tree. And again, like a tree, you have the application, which is the CEO, you have the supervisor, which is the manager, and you have the worker. I've explained to you that if the supervisor fails, the application will bring one up, and from there it will bring those workers back. And this works all the way down, and you can have as many levels as you want. You just need to be really careful to make sense, otherwise you'll have pains in production. But otherwise, it's really straightforward, and you can look at it. It's something you can see. You see the tree of stuff and their life cycle. And this also gives us some strategies, because I've told you that they can bring back workers. But let's imagine that the worker 2.1 is really, really important. And worker 2.2 depends on that worker for some reason. Let's imagine a database. So worker 2.1 is a database accessor or a client, and the guy down below is some business layer that needs to contact the guy above. So if the guy above fails, what happens? Does the second guy keep going? What the hell can happen? And that's why Erlang has the concept of strategies. You need to tell them how to actually handle failure. And you can do this easily, because there are only 3. There's a 4th one, but I really advise not to use it. Only with a certain aspects. The idea is, so you are a manager, and I need to understand how I bring back that work. Cool. If this idea of one-to-one, it's basically, okay, worker 2.1 died. Cool, then bring it back. Don't do anything else, just bring it back. It's an isolated case, he'll handle it. If he comes back, none of the other workers will feel anything, it's fine. If you're feeling pain, so if worker 2.1 depends on worker 2.2 and so on, you can actually give it almost a serial killer attitude, which is, okay, worker 2.1 failed, kill everything. So basically, just dump everything, just cut it in half, I don't care, just kill everything. And then bring it back. And this is a good way of, if you have a life cycle that depends on connection, for example, you can go, okay, this guy failed. I need to be sure that when I bring this guy back, worker 2.1, everything else gets the new connection, gets the new information. So this is the way you do it. But there's a smarter way, which is RESTful 1. So if you go to the code, this is a list. So this is a representation of a list, and it gives you an order on how the kids should be brought back, how your workers should be brought back. And this RESTful 1 does exactly that. Basically goes, okay, 2.1 died. So everything below me gets killed, everything above me, we don't mess with it, just bring back the kids that are below me. So it has some logic to it that really can make these supervision trees really complex, but at the same time, really resilient. And now the outlier, a simple one-for-one, it's used when you want to create dynamic workers. Basically, you call a process, better, you call a supervisor, the supervisor creates a worker on the fly, and probably he'll live for a couple of minutes and die later. But this is a really special use case, and there's ways around it, but that alone is a talk. So let's avoid it. And why do we do this? Why is there the mentality of killing and bringing back? Why don't we handle exceptions? Why do we try to do this? Because Erlang believes that there's no way everyone can catch every exception. There's no way to do it. And basically, if you try to do that, you'll end up with that secondary exception path of how to handle failure. You'll end up with if, null, or try catch in your code that needs to be thrown around, needs to be handled. It's just a secondary path that needs attention when you shouldn't care about it. If you know how to handle failure, if you know how to use failure in your advantage, you don't need to handle exceptions. You lead with the happy path, and if it fails, you need to trust your manager that he's doing his own job. So it's a really controversial topic because, again, people are not really used to the idea of, yeah, cool, my program just crashed. That's exactly what I wanted. Because that sounds weird. But it usually brings up systems that are more resilient, because if you know how to handle failure, usually you don't need as much code. It's easier to control it, and you'll know exactly, okay, it failed because of this. It doesn't have secondary paths. It's this and this only. There are mechanisms to catch exceptions, of course, but usually, at least I try to avoid them. But that's it. So let's go back to code. Now that we have our manager, we have our first worker, I want to do something with it. And this something is upload controller, which is basically in our front end. If I want to change it, yeah. We just have browse, choose file, upload. So to actually upload something, we do this. And since our process worker complies to the gen server contract, we have the gen server call, we define the process by its name, and then we send a message with the structure. Okay, this is my type, this is my path. Cool, done. Then we need to understand what type it is. So this is another cool trick, which is instead of chaining ifs and elses, just have a mess of code. You can use cont, and this is a good thing to have in your code. You'll start to see code in a really interesting way. And the other good part is, well, our default use case, our default fallback, if I don't know the content type, I'll just fail. And that failure is error. So it will be put back on type contents underscore type. The process will receive a message saying error. But on the process side, what it actually happens is, I don't know that message. I don't care. I'll fail, whatever. You guys handle this problem. I don't care about this. So this, again, gives us a good amount of control. Imagine that we receive something that no one expected. I don't know, XML, something stupid like that. And when we receive that, we basically go, error. I don't care. It just fails. I know that my manager will pick me up and I'll be happy with it. So, with that said, oh, by the way, this is how you actually do regex in Elixir. So, it's quite useful to know this one. But again, everything is really well documented. So, go back to this. So we finished that. Now comes the other interesting part, which is we need to communicate with our worker. I haven't said what worker is. Worker is another guy living in another place that just exists somewhere. So what actually it is this? Is it a web API? Usually we'd go, okay, let's create a web API. Let's do a post, send a file, and what I expect back is a response with all the pixels. The web API is kind of, meh, we can do something fancier. So Erlang has the distribution side of it. And the distribution side of it is one of the best selling points of it, because it has the Erlang Distribution protocol, which is a really bureaucratic way of saying it knows how to talk with people. Because it basically specifies a contract where it goes, okay, an Erlang string is this amount of bytes until here, it's an identifier, something else, It just shows you how to build a message that Erlang will understand. And people have taken advantage of this to have Ruby, to have Python and other languages directly talking with Erlang applications. And you can also do Java. So the Erlang guys developed a Java interface where basically you have a completely transparent node connected to a JVM. So JVM is talking with the Erlang VM, and for the Erlang VM is transparent, and for the Java side is also transparent. The guys don't even know their different languages, they don't know their different VMs, they just work together because there's a contract between them that can be complied to. So knowing the latest trends, and knowing that it seems it was the main language talked about during the Stack Overflow survey, we'll actually start a small Kotlin application. So on this side, we have our Kotlin code. There's nothing special about this. The only thing we did special is this line, where we teach, basically, the Java side to talk with Erlang. It's a package that you can download easily. And what we actually do is, since we need to emulate what processes are doing on the Erlang side, what's actually happening is, you're saying, okay, I'm a node, I'm an Erlang node, and my mailbox, it's this one. So in our case, our mailbox, it's something called mailbox, because I'm not original, and it basically connects to the Erlang VM, and they can talk easily. If everything went well, this failed. Beautiful. Because to actually make this work, we need to tell to both sides that they need to connect. So this is how you say to connect in Elixir. We're basically saying, okay, we will have a server on localhost. Use short names because this can be used with full network support and so on. And you have a secret, which is basically a secret handshake, but it's not safe. It's not SSL compliant. You can do that, but be aware if you use this in production, this will not guarantee secure messaging. Now, if everything goes well again, this guy will fail. So if we do this, now it fails. Because there's one missing piece to this. You actually need something called the Erlang port mapper daemon. What this guy basically is a gatekeeper. Someone knocks at his door and says, hey, my name is something, my secret is this, and I'm here. And the Erlang port mapper just says, cool, then I'll give you this address. Whenever a guy comes talk with me, I'll direct you. And this happens to both applications. So when we start up this one, and when we start up this one, this is in debug mode. And as you can see, you have, okay, I've just received the worker, I'll name it worker 1, and I'm at the port something. Cool. Then you have down here, okay, I received the server. So at this point, we have a guy that's mediating it's not mediating the conversation, it's mediating the connections. It's basically saying, okay, this guy is here, this guy is here. It's getting them addresses. And from now on, we can actually do something with it. So there's another part we need, which is this awful code. Or at least it seems awful. But in reality, it's actually good. So first of all, we have the way to read the file, easy, nothing special. Then we actually do connect to work. It should be worker, but let's ignore my English. We'll give it the address. This was given on this side. So, yeah, my name is worker at localhost. Cool. We try to connect to it, and since we have the EPDM working, the guy goes, okay, I need to talk with that guy. And the EPDM just says, cool, go that way. And he'll be there. And they actually check if it's there, it just does a ping. That's it. Also, I need to explain why there's a pong there. Again, this is pattern matching. So, whenever, imagine that everything goes well here, everything goes well here. For some reason, I cannot ping the worker because it's down, something. The guy will go bang, if I'm not mistaken. So, a bang value appears here, and the worker just goes, this worker just goes, I'll die. If I wasn't able to handle this exception, if I wasn't able to handle this case, I'm not doing any more work. Handle your stuff first, and then I'll do my stuff. But if everything goes well, it actually draws a tuple with an OK, saying, yeah, fine, and the node which he wants to connect, which is the address. Simple. Then on the process file, so we go back to this side, we need to prepare a message. We need to bundle up a message that the other guy will understand. So that format, it's my own, it's not an Erlang thing. For me, I wanted to send the type. So when I get back to the Kotlin side, I can say, okay, this is how you handle an image. This is how you handle video. So that's basically what this guy is doing. Self, it's basically attaching my address, so this worker's address, back to the other address. So the other guy can actually, okay, I need to send back the response. Because in this case, we are not complying to Jet server, we need to give it some extra information. And that extra information is my own address. That's fine. And then, finally, we need to give it the file path, which is the string to char list file path, and the content, so the binary array with everything. So we need to do an extra step here, which is string to char list, because unfortunately, Erlang is really bad at handling strings. It's one of the improvements that Elixir does. It's actually handling UTF strings in code. Erlang is really bad with this. So we actually need to translate our strings to Erlang strings. We can show that on the console. So imagine that you have, where is it? List. Yeah. It's a small difference. It's down here. It's not a lot. Let me do that. But basically, the difference is if you see single quotes, then it's an Erlang string. Otherwise, it's a Elixir string. But this is one of the pitfalls and one of the weirdest things you need to handle between both of them. But to be honest, it's not that bad. There are worse things in other places. But yeah, on this side, just arrive, it will see, okay, I know what an image is. I know that I have my sender, which is the guy that sent me work. And I know that I have content. That content is inside the tuple, where I can actually have, I'll send that content to process image, and that process image will have a way to extract that information. So if we go there, intelligent, nothing. No, not this time with this. Basically, the content is destroyed, it's deconstructed, and you'll have the path, and you'll have the content itself. So, at this point, that's actually not looking that bad. We've made a lot of work that, without a lot of ease, it's not that complicated. And by this point, don't forget that we have a supervision tree created. We have something that's resilient to failure, that wasn't that costly. And we have two different VMs talking with each other with not a lot of effort. Now, we actually need to send back, we need to receive the work from our worker. We need to parse that information and understand it. Okay? So I actually want to show you guys what happens when this fails. So imagine, don't forget that now we can upload stuff, so let's enjoy that, and it fails completely. From the worker side, it says, yeah, cool, I've processed an image, it has this amount of pixels, and I'm done, I don't care. But if you go back to this guy, the guy just panics. The hell, what was this? What are you sending me? This is an unexpected message, as you can see up above. And the first advice it gives us is, okay, I received something I don't know, please help me. The guy goes, yeah, unexpected message. So I need to comply to that format. I need to receive an image with a list of values. And the list of values is the alpha value, where the pixel is located. Okay, then since like I've mentioned before, this doesn't comply to the gen server, this communication between JVM and Erlang. So we need to use the extra special case, which is this guy. This guy is the one that receives everything. It just doesn't have any kind of, he doesn't care, he's a badass. So as long as it pattern matches with this, we want to see it. We don't care about anything else, we just want to see it. So we don't need to restart, I just want to be sure everything works, because when workers die, if I recompiled, it would wake up with the new code. But since I'm not sure, I don't want to risk it. And now, we basically added that new contract. And now our worker says, cool. That's exactly what I wanted. Done. And at this point, we actually completed the communication between two VMs, completely different VMs, with completely different code bases, and they worked. They were able to talk. But let's go into the final step, which is actually sending something from a client. So to do that, the lesson learned is, do you want the process guy to do it? Hell no. No, leave it doing his own thing. Let's create a guy that knows how to handle this. Nice, yeah. Let's create it. We'll go to the sender. We'll go, yeah, I want a gen server. That's it. Quick code, nothing special. The big difference is that, imagine that you want to retain state. How do you do that? Imagine that I receive a call with a 0 and I want to increment it. How do you say to the process, yes, just store that value and keep incrementing on that? Well, processes have a really special place in their heart for state because they can control it really easily. So the state is associated with message received. What this means is, whenever you receive a message, it will respect the order it needs to respect, and the state will be updated according to that. And this is something given by Gen Server. So the Gen Server gives you a special place where you can store your stuff, but it respects order, and it respects the message it receives. So you can just iterate over that state with a lot of control. There's no way this state will go completely bonkers and mutate for some reason. No, everything is controlled because it receives a message, change state, okay, my new state is this one. So we can keep going, that's fine. So it's a really good way of handling concurrency. Because you don't have mutations, you just have something that receives something and does something. But everything is controlled by order. And that's a big thing. Otherwise you'll end up with a lot of pain. So, okay, we have our new worker. The guy is awesome. Our new hire looks really good. And we go to his manager and just present him. Here, this is your new worker. Go lunch with him, have fun. The guy's cool. And to prove that, we can show again. We can show again observer. Now, when we go to our manager, you'll have the two workers. They're living happily ever after until one of them dies because he screwed up something. And at this point, what we need? Well, the next step is actually sending the pixels we received from our outbound site, send it to the sender. So the guy knows how to, well, what do I need to send? What the hell, I don't have any work. So what do I need to do? And this is a good example of that idea of failure one rest for all and so on. Because imagine that we have, in our case, we have fixed names for a process, but imagine they're not fixed. Imagine that you need to inform the guy below what's my address. Well, if the guy above fails, that guy will have an updated address. So the supervisor doesn't know how to handle that. So the best way is, okay, then kill them all and start new. Our life cycle will be completely new, refreshed. Everything will be fine. So this is a good example on how processes can be dependent on each other. And so we got here. And what we need to do now is basically close this one. It's basically say, okay, since we're using gen server, we can use the same contract as the other guy. We'll use handle something. And in this case specifically, I really don't care. The process doesn't care about the response. The guy will just go, yeah, whatever. Whenever I receive a message, just send it. I really don't care about this. So we just fire and forget. We use cast, and on the sender side, we'll have this guy that complies to this message and receives this state. So the first run will receive this state, and this will be included on our third document. So again, we have a contract, and here we have more pattern matching. Believe me, when we start doing pattern matching, you'll see beauty. It's something that makes your code really readable, and I think it's the next step of your code is your documentation. This is a really good example. Not a good example because this is far from good, but what we're doing there is, okay, so I want to have, I know I have a state, but from that state, I know it's a map, so I want to extract this key. Okay, then what's the name for it? Cool, sockets, that's it. So this creates a binding that will grab this map, deconstruct it, grab these sockets, and this will be useful everywhere you go. You can use this at this point. You're fine. I'll show you how to use it later in a second. But yeah, this is how you do it. And this is basically the IO inspect means you're putting to the console the structure. So this is the smart way to do it, and avoids a lot of issues because IO-Puts doesn't work with maps and stuff like that. IO-Puts is the normal print line. This is the special print line. But yeah, so now our worker is sending message to our processor. Our processor is sending messages to our sender, and our sender needs to do something with them. So to achieve that next step, we actually need to understand when someone connects. So when someone on the client side connects, which is WebSockets, basically sends a message to this guy, and this guy needs to warn the sender, basically saying, okay, I have a new socket that interests you. So to actually do that, we go to our emoji channel. This is basically, Phoenix is the web framework that you see a lot if you start to work with Elixir, and this is the way they handle WebSockets. For now, just know that this is how you accept a socket, this is how it finishes the connection, and while it finishes the connection, you actually can use it to other purposes, which is exactly what we want to do. I want to store that socket and say, yeah, that's the guy, one of the guys I want to send. So you'll arrive here. and go, cool. Then, whenever I receive an handle call, and in this case we want to know, because if anything fails, that connection shouldn't be there. That connection should be killed. To be killed, well, we just don't get the pattern matching okay. It should die, and Phoenix knows how to handle that. So it complies to that. It doesn't care. So what we do is send the socket, just warn that it's a giant socket. You can be really specific with this. I wasn't, but please be. And in this side we'll have, okay, we'll create a guy that knows how to handle the new client. To handle that new client, we actually need the state. Because that state is the one that will be used by handlecast to actually send. So we need to update that state to have that new element. And this code looks really ugly, but the only thing it's doing is, this is creating a new list. So it's basically grabbing, again, it's grabbing the binding from this guy, pulling it down, yeah, I can use it here, and then I'm adding a socket. There's other methods to do this. I feel that this is the easy one. I'm really lazy with this. So we basically put that socket on a list, and we just concat lists, that's it. The unique byte is a function of the core library, from the enum core library, that basically says, okay, please filter or give me the unique elements. Usually you can do this easily, but since we are working with a really weird map, because the socket has a lot of information, I'll tell him, okay, you are unique if you have this ID. This is part of the structure of the Phoenix channel, of the socket Phoenix channel. And I'll say, okay, if you, basically the same deconstruction as here, I know that you have a key called a sign. Inside of it, I know you have a map. And inside of it, I want to get the ID height. And if the ID is equal to the other guy, then you're unique. So this is the way to say, yeah, this guy is unique, I want to store it, and I want to keep it. Otherwise, you'll just see messages going to the same guy because you're just storing whatever. This way you can actually filter out, okay, this is my subset of sockets because I know they're unique. And you should be really careful with WebSockets because since they are reconnect mechanisms, you can end up with repeated messages going there. Nice. Now, what we have? This is something I actually forgot to explain, but it's part of the gen server protocol. So at the end of any handle call, handlecast, and so on, you need to warn gen server what you need to do with it. So in the case of fire and forget, we'll just give it a tuple of no reply, that's it, I don't care about it, and state. That state is the next step, so it's the next step of our list. This one, since it's a gen call, you know you need to reply. So you give what he needs to reply. This is basically, the other guy will receive this. And when the other guy receives this, that's it. But you can do this as complex as you want. You can have a really big structure here, you can do whatever. And then, this is the really lazy way of updating a map. What we're doing here is giving a state, which is the original parameter. We're saying, okay, when you find the sockets key, update it with our new list. And that's it. That's basically a really short way of updating the map in Elixir. And with this, we finally have the sender with all the information required to actually send a message through the WebSocket. And how do we do that? Well, we use whatever we have to actually do it, which is on our handlecast, we have the sockets that arrive from our state, which was passed on here. So basically, when a guy connects, it updates. Okay, I have my state is this one. I'll receive a message of, okay, I've processed my information, so send it. So it grabs the sockets, which are our destinations, and it runs set content. This is how we do lambda functions, really small lambda functions in Elixir. So it's basically saying, okay, do the set function with the first argument. Here, the second one is content. So what it does is socket/content. And now, we think we are really smart. So we want to do this asynchronously. And since this in any other language would probably be create new thread, create a runnable, and so on, and here you go, do this asynchronously. In our case, since everything is a process, we use task async, and that creates a new process. So inside this block, the guy knows, okay, task async, give me the function I need to run. It runs that. Whenever it finishes, it sends back to the parent a message saying, yeah, I'm done. My work is done. And this is another example of, yeah, you just create a worker, you just create a guy below you, and you need to know how to handle the messages above. So I have a new intern guy. The guy is still learning, came out of college. I said to him, yeah, just give these papers to Alice. The guy goes run, brings back, and says, I finished. Cool, that's it. Go drink some coffee, I don't care. And if everything goes well, which I hopefully do, when we do this, we have a full circle. Hopefully. Yeah. So we've just made a small example of highly complex supervision tree. Not highly complex, it really is, but it's a new concept, but still. We have a supervision tree talking, or an Erlang supervision thingy, talking with the JVM, bringing it back, grabbing the information it did, and send it to a WebSocket. And to kind of prove that this is fast, you can actually upload a video, and it shows frame by frame updating. And of course it needs to be the emoji trailer. And that's it. The only thing actually limiting us here, it's my lack of front-end skills, because I'm using Canvas to draw everything. And when you're dealing with pixels, it's a lot of pixels. And the other thing that's limiting it, it's actually one of the biggest problems I had, was actually showing it working, because it was too fast. And this is a weird thing to say, but it sounds really arrogant. But since Erlang, it has really lightweight processors, it's really good for that. And the JVM is also really optimized. The frames are being processed too fast, it would send them too quickly to our processor. The processor guy in Elixir would send it through the WebSocket, but it would send thousands of images at the same time. I've tried this with big videos. It doesn't work well. Basically, it's just see flashes of emojis. That's something we don't want. And that's basically it. We achieved our $1 million idea. We can do paintings with emojis. Tell me if that's it. And a final shout out to Lisbon Elixir. This is a young community still, but I do believe this is something, a language that will get traction in the future. It's really simple, it's really interesting, it has a lot of superpowers. The biggest downside is library support. That will be your artist cell, but again, since you can actually communicate with other languages, what you can actually do is, and some people do this, it's having, okay, I want to talk with Cassandra, so I have a JVM guy that does that. It knows how to handle that. And it works as an Erlang worker. Then we have a processor guy doing the business stuff. Yeah, just save this. Still, be careful, this is not optimal, far from it, but it's a shortcut. So, yeah, that's it. Any questions, anything? Please ping me. Any questions, nothing?
Okay, in the beginning, okay, first of all, thanks for this talk. In the beginning, you talked about, it's not really about the presentation, it's more about the language. You said like, you have like good selling points and probably like things that are making it hard to sell. Can you elaborate a little bit on your experience?
Personal experience?
Yeah,
like I've said
a little bit about the libraries and everything, but
yeah, the library thing is the biggest one, to be honest, because we tried to work with Cassandra, and that was a pain, because you look at the library and you see, yeah, this seems to work, and then you go to the roadmap and you see that SSL isn't implemented, authentication is not implemented, and then you try to go, okay, I can use Erlang, because Erlang interop is really good. But then you look at the Erlang side, and you'll see that the guy doesn't update that project that much. So you'll end up with a feeling of, it seems that the supporter, the contributor, the main contributor, it's kind of slow updating it, and that's fair. Most open source projects have kind of that problem, but with Cassandra was really bad. And when they started supporting the authentication part of it, it was the only missing piece for us. It was really easy to develop on it, but still had some kind of weird quirks. For example, if you connected to, it had different behaviors. So if you connected to a single node, it would behave in one way. If you connected to a cluster, it would behave another way. So it's weird. And there are the other examples. For example, Mongo, which is a really common database. The first lib to use it wasn't really that good. It got better. Now there's a different version. And even Ecto, for example. Ecto didn't know how to use the Mongo connection for a while. You need to use Ecto 1 and not Ecto 2, and everything got good, mumble jumble. So that's the feeling. By the way, Ecto is the ORM, lean ORM of Elixir. It's also a really interesting project. I also advise you to take a look at it. But yeah, that's my biggest problem now with Elixir and trying to sell Elixir is if someone arrives to me and says, I want to do something in Elixir. Cool, are you using Postgres? No, then be careful. Because Postgres is really well supported, it's really cool, but everything else is kind of not there yet. That's at least my opinion. And I think that will be the biggest difficulty selling Erlang / Elixir 21. But other than that, there's actually really good libraries coming out. There's really good stuff coming out. So, I think it will gain more traction, and bigger companies are actually starting to support it. So I'm really hopeful it goes well. Hopeful, because I think this language is really awesome. Yeah. Thanks.
I was going to ask something similar, because I've been hearing about Elixir for 2-3 years now, and I was curious to know about how the ecosystem now. But I can do another question, because from all this time I've been always hearing that Elixir will be the next step for example, Ruby developers. But I'm not seeing the bang happening. Well,
to be honest,
what's your opinion about the current presence of Elixir among the developers?
To be honest, that point is a bit tricky, because this talk, for example, is kind of weird because it touches in a lot of stuff. I know that it's a bit overloaded, and this is still the top layer of what Elixir is able to do. And it's a lot of new concepts. There's a lot of new things happening here. So if you go to someone and say, yeah, I want an MVP working in X amount of time, choose your language. You look at your development team, and you'll say, do you want to try Elixir? And probably they'll just say, some guys will say, what's the deadline? Some guys will say, no, I like Ruby, that's it. So I think that attraction of a language is measured by the willingness of people accepting it. And I think people are accepting Elixir, but at the end of the day, there's a lot of new complex stuff underneath that people need to understand before starting working with Elixir. It's the same as, I'm a really advocate for Clojure. I really love Clojure. But trying to sell Clojure to anyone, it will be a pain, because the first thing they'll say, too many parentheses, because they don't want to see anything else. Then what they'll say, why the hell do I need this? And then they'll say, async, why? Why do you want channels? And again, if you look at the language, it's really solid. The same with Elixir. It has more support, but that will change in time because code is older. And it has really a really solid foundation, and also it has really good syntax. I prefer the Elixir syntax other than Erlang. It's almost comparing Kotlin to Java. It's more lenient, it's nicer to read, it's just kinder to your eyes. And I think that will be a big selling point. And Ruby guys will, sooner or later, will catch the end of it. Not to catch the end of it, but be more impressed with it and start. Because it has a really similar syntax. Anything else?
I had the impression that Elixir and Erlang were a bit further apart. As far as I've seen from your demo, you still need to rely a lot in Erlang, right?
Yeah.
So if you don't know Erlang, you don't know Elixir.
You can work without Erlang. What I'm doing, since I'm using the Erlang Distribution protocol, I was a bit forced to know a bit of Erlang, mainly the string side of it. But you can know Elixir without knowing Erlang. If you want to go low level, yeah, you need to know a bit. Because if you ask me how to program probably this in Erlang, I wouldn't be able to do it. And even my cream knowledge of Erlang, which is just a scheme over it, nothing else, I kind of know, but lower than that, completely different world for me. And I had to do Erlang interop, because Elixir and Erlang, since they're really tight, the interoperability is actually really easy. So for example, this, let me give something as an example, crypto maybe. So this thing that I'm showing is, this is Erlang code. So again, since Erlang and Elixir are hand in hand, interop is really easy. Just put colon, the module, dot, whatever. So it's actually really easy, but again, you don't need to know Erlang. Please try Elixir without that burden, because you'll find a pleasant life with Elixir. It's really, really good. But I advise to, when we want to do something more advanced, just take a look at the Erlang docs. They're actually really, really good. They're well structured. And if you have any doubt, there's a lot of places you can ask. And they're really, actually, the community is really helpful. Anything else? No? Thank you guys for being here. I know it was rainy, so I really am thankful for you guys being here. So, yeah, see you.